Today our topic is transformation of coordinate axis. So before starting this, let's recall what is meant by a coordinate system. So there are so many coordinate systems like Cartesian coordinate system, polar coordinate system, oblique coordinate system. So we here define what is a Cartesian coordinate system. This system is due to a French mathematician Descartes. So it is defined as, in a plane we take one horizontal line called x-axis and a vertical line called y-axis. At any point in this plane, P is designated by a pair x naught comma y naught, where this x naught is perpendicular distance of point P from the y-axis. So this distance, this is x naught, and y naught is perpendicular distance of P from the x-axis. So this distance is y naught. In this way we have coordinates of the point P, and the point where these two axes meet is called origin. In right to origin we write distances in positive numbers, and in left to origin we write distances in negative numbers. Similarly, in upward direction we write positive values of y-axis, and in downward direction we write negative values of y-axis. Suppose this frame of reference has two lines, one is horizontal line, another is vertical line, where they meet is called origin. All distances are measured from the origin. So this is all about the coordinate axis. Now suppose I pick this frame of reference from this point and place somewhere else. Suppose I place this system here with a condition that the old axis and new axis are parallel to each other. So this is new horizontal x-axis, this is x dash, this is new vertical y-axis called y dash, and this is new origin, call it o dash. Now the question is, if x naught dash y naught dash are coordinates of the point P with respect to new coordinate axis, then what is the relation between the old coordinate system and new coordinate? Then this point will have coordinates h comma k with respect to old coordinate axis. With respect to new coordinate axis, it is origin, so it has coordinates 0, 0. But with respect to old coordinate system, I assume that I am given, when I move this coordinate axis, I move h units in x direction and k units in y direction. Therefore, this has coordinates h, k with respect to old coordinate system. So now, what is this length x naught? Now x naught is equal to this distance. So I can break this distance in two parts, this plus this, but this distance is equal to this distance, and this is h. So I can write this as h plus this distance and this distance. This is x naught dash, this is x naught dash. So consider this rectangle. In this rectangle, this thing is h, therefore this thing is h, and this thing is x naught dash, therefore this thing is x naught dash. So total thing is h plus x naught dash is x naught. Similarly, this height y naught is equal to, so y naught is from this point to this point. This point is y naught, this length. I can break this length in two parts, this plus this. This height is y naught dash and this height is k, because second coordinate here is k. So this is k plus y naught dash. So this is relation between the new coordinate system and the old coordinate system. So let's see one particular example where I can explain this more. Let x minus 1 square plus y minus 2 square is equal to 4. We all know that this is equation of a circle with center at point 1, 2 and radius 2 units. And if we plot this curve, then this is center is at x1 and y2. So this is center and radius is 2. So this is radius. So the curve is this with respect to the x-axis and y-axis. Now suppose I pick this frame of reference from this point and place at the center of the circle. Which is 1, 2. So that is, I shift the origin from 0, 0 to 1, 2. Then what will be the new equation of this circle? So we have this relation. So if we shift the coordinate at point hk, the new coordinates x0 dash y0 dash and old coordinates x0 y0 has this relation. So x0 or x is equal to x plus 1, y is equal to y dash plus 1, x equal to x dash plus 1, y equal to y dash plus 2. Substitute these values here, we get, on substituting x dash plus 1 here, 1 and minus 1 will cancel each other, y dash plus 2 here, 2 and 2 dash cancel each other, so we get x dash square plus y dash square is equal to 4. So this equation and this equation appears different. This has become simpler than this equation, but the graph is same. This equation represents this circle, this equation also represents this circle. The difference is, earlier my frame of reference was this, now the frame of reference is this. So with respect to new frame of reference, the center of this circle has become 0, 0 and the radius is 2. So center has changed from point 1, 2 to 0, 0, but radius earlier was 2 and now is 2. So it means when we change my coordinate axis, there are certain things which remains invariant and there are certain things which are changing. So it is natural to ask what things will remain invariant if I shift my origin keeping my coordinate axis parallel to the original axis.
We shall discuss this at length, but before that, consider one more example.
Consider this equation: x square plus 2y square minus 6x plus 16y plus 39 equal to 0. The question is, rewrite this equation by shifting the origin at the point 3 comma minus 5. Simplify by shifting the origin at point 3 comma minus 4. Here the question is, simplify this equation by shifting the origin at this point. So I want to make one point clear that it is not always the case that whenever I make the shift of origin keeping my axis parallel to the original axis, the equation is going to be simplified. I don't know the equation will going to be simplified or it may become a complex equation. But let's see what happens if I make the shift of origin. So old coordinate system is this, and I have shifted the coordinate system to a new point 3 comma minus 4, 1 2 3 and 4 unit 1 2 3 4 below. So this is the point where I have shifted. The new coordinate system is x dash y dash. So this point is 3 comma minus 4 and this point is 0 0. So the relation between the new coordinate system and old coordinate system, we have just seen that x is equal to x dash plus h, y is equal to y dash plus k. Here the points h, k are these points 3 and minus 4. So I substitute here. So this is x dash plus 3 and y dash minus 4. So substitute for x and y in this equation, we get x dash plus 3 whole square plus 2 into y dash minus 4 whole square minus 6 into x dash plus 3 plus 16 into y dash minus 4 plus 39 is equal to 0. So this implies from here constant term is minus 64 and this is 39 is equal to 0. So now see what this equation becomes. So this becomes x dash square plus 2 y dash square minus 2 is equal to 0. So this is new simplified equation. So see after making the shift of origin, keeping our coordinate axis parallel to the original, we have got a new equation which is a simplified equation of the given equation. One more thing I can see from this simplified equation is, you have already studied conic section in your +2 classes, where you have seen the equation of parabola, hyperbola and ellipse. So you can easily recognize this equation. This is equation of ellipse. So I can write this equation as x dash square over 1 plus y dash square x dash square over 2 plus y dash square over 1 is equal to 1. So this is equation of ellipse. You can compare it with the standard equation x square over a square plus y square over b square equal to 1 is the standard equation of ellipse. So it means by making change of coordinate, we can identify our curve, what this curve is. So from here we can't see whether it will be a parabola, hyperbola or ellipse. I can only see that it can't be a circle, because if a second degree equation in xy represent a circle, then coefficient of x square and y square has to be same. So here the coefficient of x square and y square are not same. It means I only know that this equation doesn't represent a circle. But second degree equation may represent a pair of straight lines, may represent a ellipse, may represent hyperbola, parabola or any other conic. So but after making the shift of origin, we have concluded that this second degree equation represents a ellipse. So this is one use why we are interested in studying the shift of origin, keeping our coordinate axis parallel to the original axis. Now our next topic will be, we shall not shift the origin, we shall rotate our coordinate axis by keeping our origin at the same point. Suppose I have given a frame of reference, I will rotate that frame of reference at theta degree, keeping my origin fixed. Then we shall see what is the relation between the new set of coordinates and old set of coordinates, and what is use